something about these structures. And we were able, using methodology from physics and other fields of science, to actually calculate the complexity of each scale. And we showed that there is in mathematical form, we showed that there are no two scales of the same type.
The same way as we are certain that there are no two unique fingerprints, there are no two unique butterfly scale. The first step is actually to get the butterfly scale, and there is high density of scales per wing. Okay, so 100,000 scales you can find at a single wing. So it means that you don't have to have many butterflies.
Then we use this idea and this methodology to actually develop reading algorithm, which allows us to read this information from scales and actually compare them.
So you had to prove two things here. The mathematical proof that a scale from a given butterfly is unique anywhere in the world amongst all butterfly populations, and you had to show proof of principle that you could distinguish one from the other electronically.
Yes, exactly. When you say mathematically, it's not exactly mathematical proof. It's actually something that comes from data science. You are able to do a certain statistical analysis that shows that there is a very, very, very small probability that there is two scales of the same type, okay? When I say it's very, very, very small probability, this probability is even smaller than the number of atoms in our universe.
Where did the idea come from to look at butterfly wings?
Actually, it started as a basic research, okay? They were interested in colors on butterflies. So that's how they started looking at scales, and then they realized that there's something more there.
And so that point about colours is really important because that gives you another dimension, basically, in the probability space. So to put that in a slightly less abstract way, I guess part of it is you have the topology of the scale, just what it looks like physically. But then overlaid onto that is colour as well then.
Well, the thing is, there are two types of colors, so to say, in a world, okay? You have colors that are a result of pigment, okay? And you have colors that are the result of structure. So you have some lattice that actually interacts with light, okay? And creates these beautiful colors and butterflies. And this is exactly what we are looking at, the structural colors, not the pigment one.
So the little unique scale comes off the structure of the butterfly wing, goes onto an asset like a card or a banknote. At the beginning of its life, you take a digital scan, a representation of that unique scale. Then this card goes off into the system. Okay, so this prototype you've created, which we have it on the desk, and there's a groove onto which we can place the card, which I'm now doing. But the bit where the scale is, this tiny microscopic scale from the butterfly wing, is now sitting over a sensor. And I guess within that sensor, you need a microscope or some way of, being able to analyze this scale.
These are quite small, so in terms of hundreds of micrometers, and then you have to see the image. That's why you have the microscope, and you have a camera which records this image and then stores this into the database, and then you compare it with its database when you read it again.
Then this card goes off into the system, ended up in a wallet in a user in London like me. I go to some kind of sensor in the middle of the UK and put this on the sensor, it gets scanned again, and those digital patterns are matched.
Exactly, and you would be the only one having this exact card, so nobody else can have exactly the same card as you.
Is it possible, though, for me to buy my own very high spec microscope, take a scan of that little structure, and then print that onto my own card and counterfeit it that way?
You might try that. The problem is that this data wouldn't be in our database then, and then you wouldn't be able to verify that this Teslagram was actually coming from us.
And I am trying to think of the practicalities of this. You literally need teams of people going out, collecting dead butterflies, hoping for perfect specimen. This is a lovely idea, but can it be mass-produced in practice?
Actually, it can be mass-produced in practice because we also develop our breeding facility. Okay, there is a possibility to breed your own butterflies and breed the specific species that you want to look at. And the best thing is that actually, as Saša said, there are a lot of scales on one wing of the butterfly. There are around 200,000 scales. So basically, using a small number of butterflies, you can protect a large number of data or any type of assets. Yes.
But how durable are these things?
Actually, the scales are made of heating. It's very durable material. Okay. Today we have butterflies that are old, I don't know, several hundreds of thousands of years. Okay. So basically, it's very resistant material. It can stand up very high temperatures. It's not affected by low temperature, and it's